Hi, I'm Lars, an engineer here at Pentair Water Solutions. Today, we are in the Pentair Water Lab in Brookfield, Wisconsin to perform a dirt loading test with a generic extruded block cartridge versus a Pentair FloPlus Fibredyne cartridge. First, we install. We are using two 10-inch heavy-duty Big Blue clear housings for this test. Installation into the housing is pretty straightforward. Just take the cartridge out of the wrapper, place it in the housing, ensuring the top of the cartridge is aligned with the top of the housing. Make sure the O-ring is set, and screw the housing onto the cap until it's tight. Same process for the generic cartridge. We are using a housing wrench to give the housing a quarter turn to ensure it's watertight. Hand tightening is usually good enough, but giving it a little extra love with the wrench ensures the smallest possible chance of leaks. Now, we're turning the water on, pressurizing, and performing a quick flush to reduce fines. Then purged all the air from the housing using the pressure relief button on the cap and dialed in the initial flow rates and pressures for the test to make sure they start in the same place. We have both set to 4 GPM going through each filter, and the pressure reads about 60 psi. This is comparable to running a 20-inch Big Blue system at 8 GPM, which could be used as a point of entry solution. The 10-inch heavy-duty systems you see here could be used as point of entry or point of use solutions. Initially, we are seeing a pressure drop of about 8 psi on the Fibredyne and about 10 psi on the extruded block. With Fibredyne, flushing is much easier. Its proprietary blend of carbon and fibers allows it to be more porous and permeable, allowing water to flow more easily. The extruded block is dense and catches more particles on its outside surface and takes more time and water to flush. Now that this has been flushing for a few minutes, we are going to start the dirt loading test. This bucket you see here is full of dirt, which, once we turn the pump on, creates a solution at about 25 NTU. For reference, municipalities must meet a turbidity of less than 1 NTU in the water they provide their customers, per the EPA's surface water treatment rule. So, this is a very accelerated test. It should be noted that the dirt used in this test is the same dirt that the NSF ANSI 42 standard uses for particulate reduction claims. It will plug up these blocks faster so we can show you just how much more efficient the Fibredyne cartridge is than a generic extruded block cartridge. This also goes to show that even with extremely challenging water conditions, the blocks will still provide filtration. So on average city or well water, these types of cartridges will perform very well for long periods of time. Now we've turned the pump on and we let it run. In the white extruded cartridge, you can see how much dirt is just sitting on the surface. With Fibredyne and the way it's constructed, we know the particles can penetrate the block and sit inside it rather than on the surface, which helps with performance over time. We took a quick sample to demonstrate that it is filtering. The dirty input water is on the left, and the clear water from the Fibredyne block is on the right. This part of the test is all about weighting. We are looking for a drop-in flow rate as the cartridges fill up with dirt. Our hypothesis is that the Fibredyne will greatly outperform the extruded block. As time passes, you can see on the left just how much the pressure drops in the extruded block and how much pressure the Fibredyne block retains. Now, we've reached the end of the test, and you can see the different water samples here. The sample on the left is the untreated dirty water. In the middle is the filtrate from the extruded block, and on the right is the filtrate from the Fibredyne block at the end of the test. As you can see, even after being hit with very harsh conditions, the blocks hold up well and continue to provide premium sediment filtration.